Nei. Heyri í mér ekki? You can hear me? I understand maybe a lot of you, even though it's in Icelandic. I want to thank Ulf for a great presentation and also for a good connecting part to my presentation. So I'm going to talk about, I call it the refuge room. I'm going to talk a little about the background, regulation and status on the refuge room or safety chambers. What are the requirements for reliable refuge room? What are design considerations? Maybe compare the solutions from the mining industry. Then I'm going to look into some calculations of limiting factors. How long can you stay in a safety chamber like this? And maybe some conclusion. I think Ulf made a good comment on we have to maybe compare safety chambers with sprinkler system, like he was mentioning. So the background, there was an this is valid for the roads on the Trans-European Network roads. There's a paragraph that says emergency exits there should be an exit on an emergency gallery, and it also states shelters with an escape route separate from the tunnel tube, and shelters without an exit leading to escape routes to the open shall not be built. But I was a little bit confused in translation, I think, because when I think of emergency gallery, and that's maybe my fault or many others, perhaps, when I think about the emergency gallery, I think about large room. I'm not sure what you think about, but so I did a little bit of digging, and usually I think I was wrong. Emergency gallery are usually defined as a small parallel tunnel. And I also looked into the regulations in each of the country. In Iceland, we call it neyðarrými, or emergency room, if I translate back to English. Norway, it's nødgallery, emergency gallery, still not sure what they are meaning. In Denmark, it's nødkorridor, or emergency corridor. It's quite easy to picture what they are meaning. In Swedish, it's utrymningsgång, or escape route, very certain what the meaning is. In Finnish, yes, thank you. Very good. Not compliant. Well, I think the intent of the EU directive is taken from a deadly Mont Blanc fire. The experience showed that people were killed inside the vehicles or refuge-like areas. They went into some technical galleries, but some of them were also saved by entering into those galleries and safe room. So yes, so the EU strategy is to have an evacuation to a safe zone leading to open air, not just waiting in place. So that's why they did it. But I think they were maybe perhaps wrong, because they were thinking about big tunnels with a lot of traffic and not the situation we have. And also, the main challenge, like Ulf mentioned, is that the main problem is to start the evacuation. People tend to wait many minutes in the car before they start to evacuate. Or like the escape strategy here in Iceland and the bidirectional tunnel is to turn around and drive out if you see a fire. And researchers also show that people get very quickly disoriented in smoke. And that's the situation we have. People are exiting their vehicles too late and they are already in smoke. So they can maybe walk a few hundred meters or 500 meters, and after 500 meters, they often just turn around. They don't know what direction they're going. So it's a very tricky situation. And the nearest exit, like we have in Iceland, is maybe 3 kilometers away or even longer. And parallel exit tunnels are not considered feasible for many tunnels. And like Ulf maybe mentioned, we are way off the green line, I think, if we want to dig parallel tunnels. Of course, that's the best solution. But we have also seen that Oslo Third Tunnel, or the Norwegians, they have built emergency shelters or refuge room. And experience from that has showed that they are effective. They can save lives. There was a truck fire, and the truck drivers, they managed to get into the room. But of course, they were a little bit shocked that it was a closed room. They were expecting to get out to the outside. So that's also something to think of. There was also extensive research, Northflu, that showed that reliable refuge rooms are an effective measure to enhance safety. So what we are usually saying, it's better than nothing. It must be better than nothing. And there was a lot better than nothing. Current status, it is in use in Oslo Third Tunnel and has saved lives. I saw it on the internet that it has been installed in Faroe Tunnel and Flekkere Tunnel, but I'm not sure if it's in use or not. I think it is in use. We have built it in 3 tunnels in Iceland, but we are not allowed to operate them because of the EU directive. So they are there, but they are not allowed to be used. So they are not ready-made. They are not finished, not completely finalized. It was considered, I know that, because I was asked to do some calculations for Estra and Sandoy Tunnel, but not sure of the status. Unfortunately, I think the changes in the EU directive are not probable in the near future, but I might be wrong. Hope so. So I'm gonna look into a little bit of the design intent. What do we need to think about? What are the requirements? How many people should a refuge room hold? What are the limiting conditions? What do we have to think about? And it has to be a simple and reliable solutions. So I compare it to a lifeboat. The design intends to create reliable refuge room. Road users might get stuck in the tunnel due to fire. So the intent is to save people from being killed in tunnel fires, like a lifeboat on open sea. Lifeboat on open sea, it's not certain that you will be saved, but you have the possibility. So we want to give the possibility to be rescued. Yeah, so what are the requirements? We have been looking into 500 meters. In Oslo, it's 250 meters. Of course, that's way better. And of course, distance also between emergency room also has effect on how many people can enter them or will enter them. I think it's useful to use in long tunnels with low traffic, where it's not possible to create exit tunnel. But like Ulf said, maybe we should also consider sprinkler system. We have to have fire brigade from both portals. They have to be able to enter from both sides because the fire ventilation, if you're stuck in a refuge room, the smoke is maybe downstream or in the tunnel, and the refuge room is stuck in smoke. So we have to turn the ventilation around so we can get the people out, rescue people. So we did consider how many people might go into such rooms. Normally, there are only a few cars in most tunnels in Iceland. So, but in extreme cases, we thought that was in 2015, 10 years ago. We thought tourist buses, maybe 2 tourist buses full of people plus some passenger vehicles might add to up to 150 persons. And when we thought this is not an extreme case. But then came the passenger cruise ships, and they tend to stop in small towns like in Ísafjörður, and there are thousands of people and they want to travel. And they have short periods of time to travel, so they go on bus trips, short bus trips. And this is the situation. A lot of people, a lot of buses, and what they do, they fill the buses and then they start driving. So what happened last year or the year before, we had a bus fire just outside one of our tunnel. And when we looked better into it, it was 5 buses traveling together. There were up to 300 buses, perhaps, not sure. But of course, it's an extreme case, but it was close to a tunnel. The fire could have been inside the tunnel. So how much time do we need inside a refuge room? We of course the time for the fire brigade to arrive, and we need some time to extinguish the fire. We need some time to rescue upstream of the fire. Upstream is where the clear smoke is entering, so those people can walk out safely. Once they are out, you can start to think about the people who are trapped in the refuge room. So the conclusion we thought was we need at least 2 to 4 hours, 450 persons for the extreme case. And when you look at the research available, you find out that 90% of all tunnel fires are extinguished within 3 or 4 hours. But of course, that leaves room for 10% that are longer. Other requirements, you have to have a vestibule or airlock or fire lock with proper fire doors. And we want to have windows because we want to attract people to go inside. So it has to have a light in the vestibule so people dare to walk in. Because that can also be a problem. So we have to have an overpressor, keep smoke out. It must be airtight, and of course this room has to be ventilated daily. And the ventilation system must have proper fire dampers. And of course we have to use the air in the tunnel to bring into the refuge room. There's no other way to bring fresh air. So the ventilation system has to shut off quickly once we get the fire signal. So this is one type of solution we have come up with. When we are digging the tunnel, we make one more or two more explosions when we are doing this technical room. So just one or two more explosions and we get this room naturally. This is a proposed look on it. This is inside one of our refuge chamber, and we wanted to have it big because it has to have room for a lot of people, but also it needs to have air for a lot of people. So all the technical requirements, and this is just a kind of proposal because we're not finalized. We of course need to have lightnings, and we wanted to have constant lighting in the vestibule or the fire lock, but sensors in the main room, and we need to have air bottles to ensure positive overpressure. So we don't want the smoke to get into the room. We need to have some kind of overpressure release valve doors with monitoring sensor temperature and so on. So when we compare the solutions to the mining system, they always have CO2 scrubber. That's kind of some crystals or material that scrubs the carbon dioxide from the air, and also a dehumidifier because it can be very humid inside. And of course, we need some practical items. And you have to think about the lifeboat. What practical items are there, or what do we need? We need to have some seats or banks for X number of peoples. We want to have at least 150 units of water, first aid kit, dry toilet, food. Not sure if the food on lifeboats. Blankets, because some tunnels are cold. So blankets are always good, and we also have to consider there might be just one person entering the room, not 150. So it could be very cold. And maybe anything else, maybe some fans in the ceiling could be a good idea, just to disturb the air and have some movement. Might make people feel better. This is a picture. We contacted one mining company for making such solutions, and they are doing tailored refuge room or a container solutions. And this is actually a container solutions in Norway when they are building tunnels. I think they're required to have like this because the workers are inside the tunnels that they are building, and they have only one single exits. So they are allowed to have rescue boats inside the tunnels, but we the people are not allowed. So it's quite a little bit strange. Yeah, and this is also from the outside, from another manufacturer. And this is inside one of the containers. And you see they have a lot of, this is a very small room, so they need an air conditioning system to get the water out of the air. And they have CO2 scrubbers, oxygen, and video monitoring and etc. So what are the limiting factors? I decided to look into two sizes, 60 square meters and 300 cubic meters. I call it the smaller, and a larger, 120 square meters and 720 cubic meters. The floor space requirement is from Norwegian standard, 0.4 square meters per person. That means more than 2 persons per square meters. It's quite tight. It's like you're on dance floor. Initial rock temperature, we looked at 50 to 25. Because in Iceland we have hot tunnels. We have tunnels that are over, can be 25 degrees inside because of geothermal activity or surrounding. Typical traffic, 750 vehicles per day and 8% heavy goods vehicles. So we thought, okay, if we have 20 vehicle stock, there might be 50 persons. If there's a bus or coach, might have 100 persons, or two buses, 150 persons. But there are more extreme cases available. But this is what I looked at. So we looked at critical levels of temperature. We know that in 30 degrees it can be very nice, but when you have 100% relative humidity, it feels like very hot, 35 to 40 degrees. So that can be very warning. So heat along with high humidity can be a problem. Oxygen. In the airplanes, we experience maybe 14 to 60% oxygen, but because there's no carbon dioxide, it is okay. Some might feel some dizziness or some kind of uncomfort. But the mining standard, they actually say 19.5%. That is, of course, because they are working for a long time. And here comes the tricky question: what should we prepare for our lifeboat or refuge room? What can we allow us to go? How low can we go? Sort of. What we want to aim for. So what I did, we aimed for 60% at least. And the CO2 concentration, the air inside here in this room might be around close to 700, 800 or 1000 ppm, and we feel okay. But we are starting to feel maybe a little bit drowsiness. But 5,000 ppm is the workplace limit. Above this is called unsafe. 10,000 ppm. That can cause problems, start to cause really big problems. And when we up to 20,000, we have a very dangerous levels. And we have to think about this is along with low oxygen also. So I did a little study on combined effects of oxygen and carbon dioxide. What controls our ventilation is the carbon dioxide in our bloods. So rising carbon dioxide means that we start to breathe more often. But if we lower the oxygen in the atmosphere, it can take days or weeks for the body to adapt. So we're not compensating for low oxygen fully. So temperature, there are two methods to calculate the temperature inside. One is a steady state, so that ends up to over 32 to 32 degrees Celsius. and the other one is transient. And that means that says that in the initial hours, temperature will only rise about a few degrees. But it's hard to predict fully, we have to test it. And maybe we're somewhere between those extremes in the first few hours. Relative humidity, we have each person gives out about 30 grams of water per hour. And for 150%, that means we are putting out 6 kilos of water. So like this graph shows, after maybe 1 or 2 hours, depending on size of chamber, we are getting it more than 100%. We are up to 100% relative humidity. That means that all the walls, they are starting to cry, and drop waters. So this is the results for the smaller. Here we assumed that we had 16 bottles of air to stay under 20,000 ppm. So it's maybe a hard graph to understand. So this here line, this is without air bottles, and this is how the concentration goes with air bottles. And this is for the oxygen, and we see that with air bottles we are very high up, and without air bottles, we go lower, but we are not near any dangerous levels. So, and this is the results for the larger room. And here I looked at, we can see that without air bottles, we are over the limits. And but way on, we can stay under 10,000 ppm. This was smaller, sorry. The larger, I will come to the conclusion, so maybe we'll just go fast over this. So this is the calculated threshold time for 150 persons. And on the left side, or the right side from your point of view, with air bottles, they were fixed so that we would reach 10,000 ppm after 4 hours. And what we see is that bigger refugee gives good extra safety, generally speaking, just quickly saying. So, conclusion, oxygen is not a limiting factor. Carbon dioxide is the limiting factor. High humidity along with high temperature will make people feel very hot. But you always need air bottles to create overpressures and lower the CO2 levels if we are not using the scrubber. There are a lot of uncertainty factors or weaknesses. The air tightness of the room, it has to be properly made with proper materials. And the linings between the concrete and the rock, they have to use some expanding fire sealant so that hot air, if you have fire outside, will not go enter the room. We have this vestibule that might leak because, especially if you have a lot of people enter the room over a long period of time, it's always being opened and perhaps letting in smoke. So that's also a big weakness in this design. So it has to be good vestibule and with very good doors. And that also this overpressure leakage valves, that's a component that might fail. And of course, maintenance and periodic testing. Like Wolf said, they had 2 months testing and maintenance. And then maybe the biggest uncertainty, how will people behave? Will someone panic and just leave the room, open the doors, or will they close the door? It's hard to predict human behavior. So that's a big uncertainty. So I think we need to use all the experience we have from the mining industry. Yes, and finally, CO2 scrubbers could be beneficial, but not necessary if the room is large. I think we will need the humidifier, are most likely needed, but we need more research and realistic testing. And we actually were planning a testing before COVID came, and somehow it just, but hopefully we can do it again. But I also seen that Norway has done a lot of testing, which we need to look into, and maybe we can get someone on our next meeting to present that more. The large rooms are inherently safer than small rooms. There are components that can fail in large room. We're not depending on as much as on air bottles in larger room as we need in smaller rooms. So refuge room need to be carefully designed, built, and tested to be reliable. So So I was taking you into the refuge room, and now we see the light in the end of the tunnel. Both my presentation is coming to a finish, and hopefully we are coming forward to be allowed to use this kind of rooms, because I'm certain they can save lives. Yes, that's about it. Thank you. Questions?
Yeah, Jonas?
Yeah, I have 2 questions. You have escape rooms, but under the EU directive, you can't open them.
Yeah.
Is that correct?
Yeah.
Have you ever tried new findings and new technology? Have you ever tried to do a call for renew trials?
Yeah.
In the EU?
We can answer that. Right. Think you tried?
Because non-EU country has ever done a trial with a new law, with the EU directive yet. So you could be the first.
I think we were hoping for Norway to be first.
Yeah.
We've had some small discussions and questions to them, but they're very strict. The answer is pretty much no unless you can.
Yeah, for now it's no.
Yeah.
And the other one, you said you need fire sealants for the rescue rooms. Is that ISO standard room corner tests fire sealant for hydrocarbon fire loads, 100 megawatt lorry fires?
That's another tricky question. Are we supposed to assume that we have the big fires just outside the refuge room, or can we assume that people will go some meters away from the fire, or
You can have fire spread to vehicles.
Yeah.
Because you have the American that will show, and then at some point it reaches the escape room that the escapee have put themselves in.
But then again, we have less traffic, so fire spread between vehicles is possible, but not as big problems. But
Third quick question. You never, because you have heated rocks in Iceland, you never have a problem with snow and ice forming in the tunnels that the cars are bringing with it?
Yes, we have in the portals in the first few hundred meters.
Yeah, I saw the cat eyes, the lightning on the floor. Is that not a problem if you got snow and ice on them and the snow flow came and ripped it off? That's not a problem?
I don't think so. It's a problem.
Thank you.
Ja, Ingi.
Ingi from Regional Directorate. Thank you for a very interesting presentation. I also have like a few questions. I was wondering, in Iceland, are all these 3 tunnels on the TNT network, or are you able to? So you have to comply with the directorate? No, the directive.
Sorry.
Are all the tunnels that this is relevant for in Iceland on the TNT network?
Yeah. We got a new regulation in Iceland for 3 years ago.
Okay.
That says that the same requirements that goes for the EU directive applies to all tunnels. So it's a bit of a self-made problem.
Yeah, but then you don't have to apply for.
No, not for them. No.
No, okay. But are you considering to do it for them?
We're trying to get the regulation changed. Yes.
Okay, so it's not relevant to have an exception from your own regulations?
We try.
Okay, interesting, okay. And I was wondering about the daily traffic in these tunnels. Is it around like 100,000 as was an example here, or was?
Yeah, all tunnels in Iceland are traffic 100,000.
Okay.
Except the only subsea tunnel, which is around 8,500.
Okay. And finally, or almost finally, is this relevant both for new and existing tunnels?
Absolutely.
Okay.
Absolutely, but we are mostly looking at putting those rooms in the tunnels that we are going to.
Okay. Okay. And finally, have you thought about like signs, how to communicate with the
Yeah. We don't think it's properly shown, but we have some lights, LED lights. On the outside.
Yeah.
Well, we have the doors, and we are planning to have lights also, LED strips on the walls, extending a few hundred meters from the door.
Have you? And it seems like it's the same sign as for an emergency exit.
Yeah.
Have you discussed that?
Yeah, we have just got.
Yeah.
And it actually says neyðarrými or escape room.
Yeah.
Or closed refuge room. But of course, it's same sign, and it's a tricky situation.
That's very interesting. Will we have access to the presentations?
All right, I think we're a bit over time, so we can continue our discussions in between coffee or during the lunch. But now it's a coffee break, and we'll be back at 11 sharp. Thank you.